So question 4 then from the 2025 Advanced Higher Paper 1. Again, you're at the beginning, so they're fairly straightforward. What we've got here, we've got two wee 2x2 matrices. Cutesy. And you've just defined this. What's 3 lots, what is this for? No, it's only the 1 mark. Plus 2 lots of B. Well, that means I'm going to have 3 of this, which is A. And I want 2 lots of this, which is B. So it's just lots of parallel calculations, which is what the purposes of matrices are. It keeps them all together. You're doing the same things to each of these. So the final answer will be another wee 2x2 matrix where you carry out these arithmetical operations. I'll have 3 of them and 2 of them, but you do it for each of the entries individually. So it's -9 plus 4, so that's a -5. You've got a 6 and a 4, which is a 10, nothing, or 0, plus 10, which is just that. And for this one, you've got a 3 and a 2 lambda. 3 plus 2 lambda. That's about it, unless you write that the other way around. Now part B says, find A dashed B where A is the transpose. So I want A dashed B. So it's going to be a product where I'm leaving B alone, but I want the transpose of this. This is where you change the row into a column. The first row becomes the first column, the second row becomes the second column. You just get them up from line there and stand them in end. So -3, 2. And same with you, up you get 0, 1. Now it's just a process for multiplying matrices. The first row produces all the first row answers. So the first row times each of these will give that'll be the first row in the first column, the first row in the second column. So you've got -6 and 0, -6. You've got -6 and 0, -6. Now the second row answers. 4 and 5, 9. 4 and lambda, well that's it, 4 plus lambda. Well that's that part then. Or rather that was the first part, that was part 1. Now there's a part 2. Find an expression for the determinant of this. Right, so I'll put part 2 here. So what's the determinant of that? Well that's just the product of the main diagonal, take away the product of the other diagonal. So it will be -6 times 4 plus lambda, take away -6 times 9. So what's that lot? So -24 minus 6 lambda, and then you've got a plus here, 54. So that will be, taking that across, 30 minus 6x. Is that what it has for? Find an expression. So there's a mark. And lastly, determine the value of lambda such that this matrix, transpose of A times B, is singular. So part 3. Now singular means it doesn't have a wee partner. It doesn't have an inverse. It's on its own. So it won't have an inverse if you can't find the inverse, because the determinant is 0. Because involved in finding the inverse, you've got to do 1 over the determinant. So it's going to be singular if that determinant is equal to 0. If 30 minus 6x is equal to 0, so 6x is 30, I'll just be able to squeeze this in, so that would be x equals, divided by the 6, 5. It'll be singular, it's not x, it's lambda. That's what I meant about that. Really annoying. So there's that lambda. Where's it going? There it's there. There it's there. There it's there. There it's there. There. Lambda equals 5.